Welcome, everyone. Before we begin the proceedings, I would like to acknowledge and pay respect to the traditional owners of the land on which we meet, the Gadigal people of the Eora Nation. It is upon their ancestral lands that the University of Sydney is built. As we share our own knowledge, teaching, learning, and research practices within this university, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. So welcome everyone to the third Australian Circular Economy Conference, this session on circular supply chains in the built environment. We are recording this session. This event is organised by the Sydney Nano Smart Sustainable Buildings Network. We have two eminent speakers joining us today. We have Harish Srivastava, the Director of Civil Engineering, Transport for New South Wales. And we have Valentina Petrone, Australia Circular Economy Lead, WSP. This session will be chaired by myself and my colleague, Dr. Ali Hadigheh. We are co-chairs of two clusters in the Smart Sustainable Buildings Network. So before we begin, I will give a short introduction of myself and then I'll pass on the stage to my colleague to introduce himself. So I'm Arunima. I am an academic at the School of Physics and the Business School. My research focuses on supply chain assessments. I do these indicator development and link those with UN Sustainable Development Goals to measure impacts embodied in supply chains, whether it be emissions or modern slavery impacts. I am co-chairing the cluster on circular economy and supply chains in the Smart Sustainable Buildings Network. Could I please now ask my colleague, Dr. Ali Hadigheh, to please introduce himself.
Thanks, Arunima. I'm Ali Hadigheh. I'm a senior lecturer and DECRA fellow, ARC DECRA fellow in the School of Civil Engineering. And I'm also co-chairing a cluster in focusing on sensors and automation as part of Sydney Nano Smart Sensing, Smart Building Network. And I'm glad to be here during this session, and I hope that everyone enjoys that.
Thank you, Ali. So the agenda for today, we have two parts to this session. I will start off by giving an overview of circular economy in construction, the Smart Sustainable Buildings Network that we have here at Sydney Nano, University of Sydney. We will then have Valentina talk about circular economy in design and construction, followed by Ali, who will give an overview of sustainable and resilient materials for net zero infrastructure, and then Harish will talk about the use of low emission building materials and recycled materials in Transport for New South Wales projects. So I'll start off by hopefully setting the scene for circular economy in construction. And I will take the perspective from the research that is happening at the University of Sydney. So at the University of Sydney, we have a Smart Sustainable Buildings Network. This network aims to bring together academics from across the university to work on problems related to circular economy. So it's about emphasizing the need for moving away from this linear economy to a circular economy and designing these materials via eco-design that achieve net zero construction through people-centric design or advanced manufacturing to really fast track the use of these advanced materials that can get us to this, to us shifting towards more a circular economy approach. So there are a number of research themes at the University of Sydney, which are led by colleagues which are part of the Smart Sustainable Buildings Network. For example, Professor Ali Abbas, he is one of the co-chairs of the Circular Construction and Supply Chains cluster within the Smart Sustainable Buildings Network. And within this network, the research looks at eco-design, advanced manufacturing, reuse, transition pathways to impact. There is a waste transformation research hub, which you can see sort of a snapshot of. So the idea really is to come up with transformative construction solutions that can focus on circular economy principles and systems thinking approaches using supply chain assessment techniques or life cycle assessment techniques for designing sustainable net zero buildings. We are also working on the supply chain aspect in detail, in the sense that we have now work being done in developing an industrial ecology virtual laboratory at the University of Sydney, which aims to consider environmental, social, and economic impacts in a holistic framework. So environmental could either be looking at biodiversity threats or emissions, energy use, sustainable use of water, land. From a social perspective, we're starting to look at modern slavery as an indicator which is of relevance to the construction sector, and the supply chains, whether they are sustainable or not from a modern slavery point of view. We have employment, occupational hazards, so accidents at work as an indicator, which we're working on in collaboration with the International Labour Organization. Holistically, in this platform that is being developed, which is the Global Industrial Ecology Virtual Laboratory. So these are these indicators which can be used for measuring the supply chain performance of construction materials and construction sectors. And the idea is to look at embodied impacts, whether it be embodied environmental impacts, embodied social impacts, or embodied economic impacts. And not just direct impacts, but also impacts in the supply chain. So if we break down the supply chain into different layers of production, we call it the production layer. So how sustainable is the chain as we go deeper into an organization or a sector, for example. So scope 1, 2, and 3 impacts. So this is all being done as a very brief snapshot as I present here as part of the Smart Sustainable Buildings Network, which brings together a number of clusters. So we have a cluster on circular construction and supply chains, but we also have on sensors and automation that Ali chairs. We have building efficiencies, we have building envelope, indoor environment, virtual design and construction, legislation, regulation, and rating schemes. So the aim of the network is to bring together expertise from different schools, science, engineering, architecture, law, and other faculties across the university in a multidisciplinary approach to really tackle this issue of circular economy in construction. So the smart building blocks, which are these built-in indoor environment, building efficiencies, and also from a management point of view. This Smart Sustainable Buildings Network brings together not just academics, but also industry and government bodies. So academics at the University of Sydney have active collaborations with United Nations Sustainable Development Solutions Network, other UN bodies, Transport for New South Wales, local governments, federal governments of other countries, GIZ, for example, in Germany, World Economic Forum, City of Sydney. So the aim really is to have an interdisciplinary approach, not just an academic approach, but also having strong links with industry. And on this, talking about industry, we are very fortunate to have Valentina with us today. Valentina Petrone is WSP's Circular Economy Lead in Australia. Valentina has unique skills combining 15 years of experience as a trained architect, focused on implementing sustainable and climate resilient practices in the built environment with in-depth knowledge of circular economy design principles for the built environment at different scales of intervention. She studied at TU Delft University, which is a leader in circular economy education in Europe, and has successfully delivered pioneering circular economy projects in Australia and a focus on community engagement. We're very fortunate to have Valentina join with us today to give us an industry perspective to talk about the need for shifting from a linear economy approach to a circular economy approach, the design principles, and of course the case studies that I'm very much looking forward to hearing. Once again, to our participants, we're going to have a Q&A at the end of the two presentations. So if you have any questions for Valentina, please post them in the chat and we'll pick those up once we have presentations from Valentina and Harish. So I'll now pass on the floor to Valentina for her presentation. Thank you, Valentina, for joining us today.
Thank you very much, Arunima, for the presentation and the introduction on the amazing work you are doing at the University of Sydney. I will share my screen as I have few slides that I would like to share with you, but by all means, feel free to add any question in the Q&A. More than happy to discuss anything that is not captured in the slides at the end. If you can please let me know when the slides are up, so I can start to talk about the topic. So I work with WSP, as Arunima mentioned, and I'm their National Circular Economy Lead. I have a background in architecture, always been interested in minimizing the impacts of what we design and construct on the built environment, with a strong focus on energy consumption reduction, water reduction, and particularly waste, which led me into this specific words of circular economy and waste management and waste generation reduction. I'm fortunate to lead a team at WSP where we are working on pioneering projects in this space, and I will share a bit more of some key projects we are working on during this presentation. So today I would like to just briefly introduce what is basically the main topic. So what is the shift that we need to do from a linear approach to a circular approach? In a nutshell, the linear approach is the way we used to live and to our behavior on any product we use daily. The simplest example is the coffee cups. We use millions of disposable coffee cups. They're just single use, so means materials are used to be produced. We use them for the time of drinking a coffee, and we're done. Unfortunately, most of the time it just ends up into landfill. Another simple example is a washing machine. So we buy the washing machine, we use it for the time it works. Then after 5 years, it breaks a piece. You call the technician, and unfortunately, most of the time, the response you get is that it will cost you probably more to repair the washing machine rather than that putting on the verge for the council collection and buy a new one. This is a very much a linear approach that we all know is not sustainable. In a circular approach, we are really trying to rethink the way we design our everyday products and even our buildings, so even the built environments. And you can see I've circled very much the word design. So the way we can shift to a circular built environment is really the changing the way we design our buildings and our products, and also we shift our behaviors. So the ultimate goal of a circular approach is to reduce the amount of raw materials we use every time, and through design choices, keep the materials and buildings in use as much as possible, as long as possible, at the highest value. And then, of course, there will be, at the end of the circle, there will be a time where materials will just need to be recycled. Some materials won't be able to be reused, upcycled, remanufactured anymore. They will become residual waste, but we really need to change the way we approach the whole cycle. So if there is one message you take away from my presentation today, I would love to be the fact that we can stop to think about waste, talk about waste, but talk about materials and opportunities. Another very powerful image is the one I have on the screen, which is basically linking back to the circular design thinking and to the need to shift of how we approach materials and the cities where we live in, is the shift from the everyone is familiar with the 3 R's. So we used to know the reduce, reuse, and recycle principle. They're still very valid, but now they are expanded. So now we talk about up to 10 R's, and where we want to really focus to promote a circular design thinking shift is the first 4 R's. So refuse. So what we can really refuse as end customers, but also as designers, how we can rethink the way we design our products and our built assets, how we can reduce the amount of raw materials we use, and how we can reuse, so keep those materials in use at the highest value for as long as possible. And then down through the pyramids, of course, all the other options are available to guide our design thinking. And how this all links back to another big topic we are discussing today. What is the link between circular economy and net zero? The graph on the slide, it is taken from a research from the Ellen MacArthur Foundation, where basically we know that we are doing an amazing job in reducing carbon emissions caused by energy generation and energy use. But what we know, according to the studies, that to achieve truly zero emissions in the built environment, we need to still tackle and address the 45% of emissions related to materials and products. So materials use and products manufacturing, and generation of additional waste components. So we know that as Arunima mentioned, 55% of the emission caused by energy production and use, they are usually embedded under the scope 1 and scope 2 emission. The big next step is how we reduce scope 3 emissions, and we really dive into those, try to achieve those targets of zero emissions. And it's very important to see that embodied carbon, definitely in terms of what we can, where we can act to reduce our emissions, is a key player, but also demolition and construction. Waste generation reduction is very important. Fit out waste also plays a big role in the scope 3 emission generation, and food waste sent to landfill, we all know, is not a good outcome for our food waste. And as I mentioned, the goal is to start from the top of the hierarchy, so really reduce what we create in the first place, and then trying to better use the materials that we still have available in the cycle. And when we get into the built environment, it's not easy to implement those 10 R's and that approach. My work, I'm very fortunate to work with design teams on multiple projects and facilitate and guide the design teams through the implementation of the so-called circular design principles and strategies. So on the left, you see the 3 key circular economy principles. First of all, as I said, we need to design out waste from the outset through good design, then keep the materials in use as much as possible, the highest value, and then how we ensure that we return materials to the system, so they don't leave the system as residual waste or downcycling, but we're trying to bring them back in a closed loop. And you can see I've listed some design strategies that we typically implement in our projects. And starting from the top, we really want to start to value what is already available in our cities on site. So what about we design for building reuse? We know there are some interesting case studies here in Sydney as well, like the Circular Key Tower. They've shown how much embodied carbon and how much money they can save by reusing and adapting the existing structures. And then how can we plan and design for longevity, which goes through across the whole life cycle of assets. We really want to select those materials that are high quality, they can last longer, and they can be easily disassembled and repaired and maintained in use. And then 1.3, what about design for flexibility and modularity? We know COVID has taught us how how changes can happen. So what about if we design our building assets that they are flexible in use? One day can be an office space, and maybe in 5 years can be reconverted into residential. And very important 1.4, the design for disassembly. There are amazing examples back in Europe on how we can design for buildings to be fully disassembled or partially disassembled once each layer of the building will reach the end of their end of use. And then under number 2, reuse existing materials as much as possible. Select products with recycled content is very important. And under the principle number 3, what if we can stop owning all the building components we use in our design, and we start to leasing products? We know in the UK there are examples of facade that can be leased. So when the building owner decides to refresh the look and feel of their building, they can just send it back to the supplier and get a new one. And that is all very important. Again, in the topic of the supply chain, how we shift also the responsibility of those components, how long they will last and how easily they can be repaired. In the following slides, I've just added a few visual examples. I always love to talk and show some research about what things could look like. So designing for longevity is very important. As you can see on the right, this is a breakdown of the concept of building by layers. So what about if we start as designer to design our building assets according to the expected longevity of each layer of the building? And as I mentioned before, what about the skin? We know the skin will last much less than a structure. So what about if we have a second skin which can be easily disassembled and replaced as needed, while we keep the structure as strong as possible? Design for flexibility. This is one of my favorite examples back in the Netherlands. Simple ways to install operable partitions and even operable planters to keep the space as flexible as possible. And back into the keeping materials in use, how can we start using product as a service? We are all familiar with lighting as a service, but even elevators that can be rented. And again, the important shift is that if we start to rent a product, then we have an agreement where we establish what are the performance expectations, and then it's up to the manufacturer and the supplier to meet those expectations agreed in a contract. So it's up to them to use their, basically they will use more durable materials, and they will be able to easily repair those elevators. So back to the example of the washing machine at the beginning, if we shift the from ownership to leasing, then basically we will push the supplier and manufacturers to being able to repair those materials. Otherwise, it will cost them too much money to run their model. So it's a shift, is economical shift as well. And looking at take-back schemes, so a famous one is the carpet ties here in Australia, where basically, if we think about any office fit out, where usually, unfortunately, at the end of the tenant's leasing agreement, everything in the office gets stripped out. Most of the time, everything ends up into landfill as fit out waste, and then the new tenant is just refitting the space from scratch. What about if we have a take-back scheme agreement? So actually, the same supplier of the carpet can come collect and remove, if needed, the old carpet and reuse it, as can be either reused as is if still valid, or at least recycling back into their own system with a guarantee of a closed loop. And then the usual big question I get asked is about, okay, but how do we realistically do it in the construction industry? And the answer is that we all key stakeholders really need to work together. So you can see in summarizing this diagram, we start from the design, trying to make the best design choices to ensure circular economy is embedded very early stage. Procurement is definitely a very key step, but even the construction phase. So we need to work with contractors and builders and actually support them and enable them in make sure that what has been designed actually becomes reality. And then if we think about the different project phases, operation phases of a built asset can be 50 years or even more. So in that space as well, there are lots of opportunities to trying to reduce any construction and demolition waste generated, and end of service is also very, very important. So we need to ensure that there is enough cooperation and communication, and materials are not just taken to landfill because that's the business as usual approach, but actually there is a conversation. And ultimately, what if the end of service just become, or end of use becomes the new first step of the design? Because if the architects and the design teams have access to the so-called materials bank, so we can access the materials that we know are already available in our cities to be used and reused as a starting point for a new building, that will definitely help us meeting those net zero targets. And in terms of embedding circular economy in design, also from project scales and initiatives, definitely needs to be a lot of collaboration across the different building scales and with government. So starting from policy and guidelines, I was pleased to be working with New South Wales DPE to deliver their first circular design guidelines for the built environment, which will be released soon. And it is very important that government really show the way and map how this transition to a circular built environment could look like. Then I've been working on 3 major master planning and precinct projects across Victoria and New South Wales. And again, there is a great opportunity at that scale, very early stage, to define the targets and set the right direction for future developments to follow the pathway to ensure circular economy principles are embedded into the design. Because as an architect, I'm well aware once the major constraints to a site has been established, then it's much more difficult to deliver a good building and achieve the good results we want to get. And then building design, of course, and selection of circular materials is very, very important. So I will just finish my contribution sharing an interesting example that we've been working on with the CSL laboratory, with we have been developing with them a circularity assessment tool, and we have started working with the design team from early in the design, talking about what are, so linking back to those design strategies, what element can be retained of the existing site, what can be refurbished. And when planning for new elements and new additions, how can we ensure those components can be easily disassembled? How can we ensure flexibility in design? And then on the back of the newly released Green Star circular economy innovation credits, we started to map out what is the difference between a standard business as usual approach to material selection to a more circular economy selection. At this stage, it is to be noted that the requirements for the credits are mainly looking at either the material has been virgin material or reused materials and the percentage of recycled content. But the next step that we are working as a team is how we can basically identify the benefits of embedding also the circular design strategies in terms of design for flexibility and disassembly. How can we really measure that and ensure that is captured? Because the challenge we see, coming from industry and talking every day with clients, and of course money is a big driver in the conversation, how we basically can demonstrate that those changes are not only beneficial to the built environment and to our whole environment and meeting net zero targets, but also ensuring we are proposing something that is commercially viable. So that is the direction where we are heading. Thank you. That's my little contribution to today's conversation. More than happy to answer any questions at the end.
Yeah. Thank you, Valentina. Very interesting to hear about the work being done at WSP. If you can please post your questions for Valentina in the chat box, and we will get to those towards the end of the session. And I'll now pass on to Ali.
Thanks. Just try to share. So I hope you can see that. Okay, thanks, Valentina and Arunima. What was mentioned in your presentations fit well into the second part of this session on sustainable and resilient materials for net zero infrastructure. So I just briefly explain and introduce the sensor and automation cluster in sustainable building network in as part of Sydney Nano Institute. So our built environment is critical for the national economy, security, and obviously health. There are great opportunities to develop innovative solutions for more efficient built environment. Of course, advances in the effective integration of sensing technologies into building environment, structural health monitoring, and environmental sensors can transform the built environment by maximizing energy efficiency, life cycle, and occupant productivity. So the university is home to various state-of-the-art facilities, such as core facility, like Research and Prototype Foundry, Sydney Manufacturing Hub, and Australian Centre for Microscopy and Microanalysis, and also research centres such as Field Robotics. For instance, through RPF, we are well positioned to fabricate advanced fiber optics for academic as well as industry research purposes. Our approach integrates a range of technologies for infrastructure monitoring and health prognosis that helps us to increase sustainability by reducing emission and also reduce consumption and environmental impact. This is mainly achieved while we also maintain occupant comfort by enhancing indoor environment quality. As a result, the vision of this cluster, sensors and automation cluster, is to use sensors in building systems for optimizing functionality and minimizing energy consumption in our building. This enables development of efficient, reliable, and functional sensing system that connect the critical environmental variables with building control system by using AI algorithms to process data and also signals from sensors in order to increase design efficiency. So on that, now I would like to introduce Mr. Harish Srivastava, Harish is currently Director of Civil Engineering within the Advanced Technical Services Unit of Infrastructure and Place Division of Transport for New South Wales. He is Transport for New South Wales representative to Smart Grid CRC and is managing a portfolio of research projects involving the development of low carbon concrete mixes, including recycled materials and sensors and digital twin based asset management technology. Harish has over 25 years of proven track record of leading the delivery of complex projects across entire assets and project life cycle, including feasibility, concept, and detailed design, construction, commissioning, and operation. Harish is recognized chartered civil and structural engineer of Engineers Australia. So by that, I leave it to you, Harish, for your presentation.
Thanks, Ali. I will try to share my screen if I can. Can you please give me a wave if you can see my screen? You can see my screen?
Yes, we can.
Okay. So thanks, Ali, for your kind introduction. I think I will probably not talk a lot about like a architectural and circularity. Probably I'll more talk as a practitioner, what we have been doing as a practitioner in transport project to improve the uptake of recycled material and how we have been managing it. And I'll also talk about some of transport policies which basically enable this. And at the end, I'll talk about some of the Smart Grid CRC project, which basically are quite relevant to this theme. So before I start, I would like to acknowledge the Wangal clan of Eora Nation and pay my respect to the traditional custodians of the lands on which we meet, especially elders past and present, and acknowledge other Aboriginal people here and their respective cultures and nation. And I guess I'll first talk about some of the framework. Probably I would not dedicate the whole session on it, but these are few important policies and procedures we have. So if we start, I start from the bottom of the slide. So these are the three key policies which underpin the sustainability in transport projects. And based on these policies, we have developed transport sustainability plan and best practice. And at the moment, we are working on a sustainable procurement framework, which is being co-designed with the industry. So I guess that's basically is the key enabler for use of recycled material or low emission building materials in our projects. Now I'll talk about some of the case studies. I guess that will be the best reflection of what we do and whether we do successfully or not do, or there is some gap. So our approach to sustainability in our projects is try to incorporate the low emission building material as best as possible, then try to replace some of the constituents of the materials with low carbon footprint material, and partially replace wherever possible the virgin material with recycled material, and then pursue dematerialization. Even if you end up using a higher strength material, and that reduces the overall quantity of the material, that is basically the best outcome in terms of sustainability. Then wherever possible, incorporate renewable energy generation facilities in our project. Good example is the picture on the right is Rooty Hill Car Park, where 1,000 PV panel, PV cells were sort of added. So thousands of, and that can generate up to 400 megawatt of electricity, which is sufficient for powering the entire car park. This car park has first time been incorporated with 10 EV charging points. Lift and all electricity can be powered by this solar panel. And there's, at the time, there's surplus energy, which is exported to grid. So this, the design sort of facilitate energy export. Now, probably I'll talk about 2 or 3 selective material. First, I'll start with cement concrete. And as we know, this is one of the most consumed material. And some stats say it's probably second most consumed material in the world after water. So in Australia, we consume about 29 million cubic meter of concrete. And if we just look at the right side, concrete is very simple mix: cement, aggregate, water, and some admixture. But if we look at the picture on the bottom, cement is about 12%. It is a typical mix, whereas aggregate is about 77%. And if we come back to left-hand side, out of the total embodied carbon of anything from 200 to 600 kg per cubic meter, about 900 to 1000 kg per cubic meter embodied carbon is attributed to cement. So that means cement, even though is only 12%, offers one of the high return sort of constituent, where if we can replace, we can get good return in terms of decarbonation or lowering the carbon footprint. Whereas aggregate, being 77% of the mix, it offers the highest opportunity for incorporating recycled material. So moving forward, these are just if you recall the second slide, where one of the pathway was to replace the high emission material with the low emission material. So supplementary cementitious material, which embodied carbon is of the order of 20 to 25 kilo per ton, which is about 1/40th to 1/50th of the cement. Probably this is one of the easy solution which can be used to replace this cement partially. And transport specifications, I have cited some numbers, allow up to 30% replacement by fly ash and about 65% use of slag. And at the moment, we are also working with the Smart Grid CRC on developing LC3, which will be an alternative binder. And the pictures on the right is actually the real-time example where transport actually use fly ash and slag as a binary or ternary blend. The next, this slide sort of shows the replacement of virgin aggregate with recycled aggregate. And our specification allow use of recycled crushed glass, recycled concrete aggregate, and manufactured sand. And picture on the right is a good example. This is a Pacific Highway construction from Ulgugla to Ballina Stretch, where about 90,000 tons of fly ash and 201 tons of recycled crushed glass was used. That was used first time on a motorway project. Just to put in the perspective, this 201 tons of glass equates to over a million beer bottles. So that's a lot of bottles to go into the road. And then, then the second material is asphalt. And again, probably we can dedicate one full session on asphalt, but just highlights is asphalt is again a mix of bitumen aggregate, and with heat input, it is converted into a blend. It is not as high emitting as concrete, but it is about 35 kilo per ton. there are certain commercial products are coming to the market, which is listed below. Probably I'm not going to read it, but basically industry is actively working at alternative products which have significant amount of the recycled material. And transport specification allow use of up to 50% RAP, which is recycled asphalt pavement. So that is quite in line with the circularity principle which Valentina was talking about. Then RCG is recycled crushed glass. Again, in the base course, we allow up to 10% of recycled crushed glass, and in the wearing course, we allow up to 2.5% of recycled crushed glass. So this is a good opportunity to incorporate recycled material. But we also use likes of crumb rubber and steel furnace slag to enhance the property of the asphalt. So, for example, crumb rubber is used to sort of enhance the reflection cracking property, resistance. And steel furnace slag is used for improving the skid resistance, which is quite important in the areas like intersections. And this slide actually shows this steel is another important material in the whole construction business. And because steel is very high emitting material, it emits about 1.9 ton carbon dioxide per ton of steel. And so there's an opportunity to reduce the carbon footprint associated with this material by substituting this with likes of FRP, fiber reinforced polymer, which has about 50% of embodied carbon. And this FRP can be used as reinforcement bars, can be used as fiber reinforcement. It can be used as the sections for fabricating the modules. It can also be used as pre-stressing tendons. In Japan, they use quite a lot of it. And pictures on the right actually are some of the examples from our project. The rightmost, this picture shows the standard design for concrete lift shaft using GFRP bars. So no steel reinforcement was used in this one. Then the picture on this picture where I'm sort of circling my cursor, or probably top left, is from the Rooty Hill car park, where basically fiber mixed with the concrete were used for installing the concrete pavement. The picture on the bottom left is from Victoria Station in Hunter region, where we use fabricated modules using FRP sections to design the sort of overlay for making it as a level access platform. And the picture in the bottom middle is from the Harbour Bridge construction, which recently completed, where we use ultra high strength performance concrete for stitching the precast pour and to meet the requirement early strength development. But we are looking to expand this material, the use of this material further in the theme to pursue the theme of dematerialization. If we use high strength material, in all likelihood, we can reduce the overall quantity of material. So that's why I wanted to touch on it. And then probably after the case studies where we have already used recycled material, probably I'll talk a little bit about the research project we are doing. Probably I'm not going to read everything. I think with the Smart Grid CRC Transport is a core partner and is undertaking research with various universities. So first in the line is with University of Sydney, and second one with the University of Queensland. And the theme of these two projects is to test a large number of recycled material in the concrete mix and see whether we can achieve an acceptable design for use of these new concrete mixes in structural and non-structural use. The project on the left we are doing with UTS, and this is the aim of this project is to use artificial amorphous silica, which is generated from mineral carbonation process in the concrete. And picture on the right, the project on the right is we are undertaking with University of Newcastle, where we are trying to develop technology to use furnace bottom ash as a SCM or fine aggregate. And the project on the left, in this case, we are undertaking with Western Sydney University, where waste lattice paint is being used to develop polymer modified concrete. And picture the project on the right is an interesting one. We are trying to analyze 400, 500 concrete mixes in our concrete mix register, and to come up with a framework where we could use recycle or probably low carbon concrete, which complies with transport specification. Because one of the complaints we are receiving all the time that any concrete mix with recycled content doesn't sort of comply with transport sort of specification. And we will potentially use this framework to test some new concrete systems, and also probably it could set foundation for developing some performance specification around embodied carbon. So at the end, probably before I launch into concrete, these are the couple of interesting pictures which shows, like, top one is use of weathering steel in the bridge. It's on the James Roos Drive, and actually it's another form of sustainability because it reduces the maintenance by removing the requirement for recurring painting. And the one in the bottom is the green track on parameter light rail, and basically this is good outcome in terms of heat island effect. So I guess with all these, probably I could demonstrate that transport has robust policies and framework for developing or delivering the environmentally sustainable project. And our specifications support use of recycled and low emission building material. And we have successfully used waste stream and low emission construction materials in our project. And we are trying to undertake further research to basically beef up this portfolio of materials available. I guess that's probably it from me. Probably I'm happy to answer any question whenever facilitators ask me to.
Thanks, Harish. I appreciate that. I think we are running short of time, so thanks for the interesting presentation and very informative. I give the session back to you, Arunima, to facilitate.
Thanks, Ali. Thanks, Harish. Very interesting to hear about the work being done at Transport for New South Wales. We have some really interesting questions in the chat box. And I would love to get to all of them, but we have just 5 minutes, so I'll see how far we get. Valentina, if I can ask you a question, there have been some comments about WSP's circularity assessment tools and whether it's possible to get access to it or to know more about the accounting boundaries. I wonder if you can talk a little bit about that, please.
Yes, so the circular assessment tool is something we are still developing in-house. So at the moment, is a tool for us that we use in supporting our clients through their design choices. So I don't know who posted the message. More than happy to have an offline conversation and see how we can help on that. Okay,
thank you. Another interesting one was about this comment about involvement of councils in desirable approach to buildings, and how quickly are these new standards being built in approval processes. I wonder if you have any thoughts on those.
Yeah, that's a very good question. So just to make a quick parallel, so for waste management, we all know that when we, a building goes for a DA approval, you must submit a waste management plan for with respect to operational and construction demolition waste. At the moment, there isn't any requirements, unfortunately, from councils with respect to circular economy. But what in New South Wales specifically, the circular design guidelines are hoping to do is to introduce this concept, and then moving forward at least the voluntary approach from there are some pioneering companies that are keen to make the next step, and then following from there, making it like a more stringent requirements.
Thank you, very interesting. Ali, can I now pass on to you? We had some questions for Harish as well, if you want to
yeah, sure. I think one of the questions I see interesting question about FRP. Bart is asking about end of life of these FRP composites, and that is true that fiber reinforcement polymer may reduce 50% of embodied carbon compared to a steel, but what is happening end of life of these FRP composites?
Yeah, I think it's a very good question, and this is an evolving probably field. It has not been probably researched to any degree, and it's a reasonable question to sort of look for end of life use. But I guess, as I understand, because it's a matrix of fiber and resin, it should be it should be possible to sort of recycle back that into some sort of the similar product. But I guess this is one of the gaps that industry needs to sort of research it further, and probably with the university representation in this forum, I guess it's a good research topic.
Yeah, actually, on that, my main research topic is on recycling of these FRP composites for construction. So, if you are interested, just contact me. I'm more than happy to discuss it further.
I'll be more than happy to discuss it offline and see where we can take it. Thanks,
Harish. Back to you, Arunima.
Yeah. Maybe I can ask a very open-ended question, and Valentina and Harish, feel free to jump in. There was a very interesting one about how exactly do you define circular flows? Is it about something that's recycled just one time or multiple times? Does the value and quality of recycled materials matter? How do you take into account downcycling? Any thoughts that you can offer on that?
To me, if I can start with that, it really goes back to those 10 R's principles. So it's looking back at the hierarchy and looking at what options are provide the best outcome in terms of retaining value. So we know that reusing a material is much better than just downcycling. So that is part of the daily conversation. At the moment, I find that circular economy sometimes is a bit there's a bit of a misconception that is just another way to call recycling. It includes recycling. It includes, of course, recycled content and all the amazing work we've seen on the presentation about transport, but there is also multiple options above that could be investigated.
Thank you. Unfortunately, I'll have to close the session because we have another one starting at 11:30. I would just like to thank Valentina and Harish for their very interesting presentations. I would also like to thank Sydney Nano for helping us organize this event, Moan in particular, and also Claire and Aaron. The questions that we couldn't get to, we've taken note of those, and I'll send an email just to everyone. So Moan would be getting in touch with our speakers to get answers for the questions that we couldn't get to. You're very welcome to get in touch with Moan for follow-ups regarding your excellent questions. Thank you to our participants. We had a very good turnout. This session wouldn't have happened without your engagement. So thanks everyone for joining us today.